Welcome, guys. I'm going to quickly go through 8-5 practice and problem solving over the mean absolute deviation in the interquartile range. Now, I just did this lesson. It took me 33 minutes. You can watch me do the entire lesson and do it with me in great detail. Or you can watch what I do right here. I'm just going to go through everything real quickly, just give you a lot of different options. You can watch the lesson live on Zoom with me. You can do it real quickly here. You can watch it in great detail. I'm trying to go above and beyond and make this as a great of experience remotely as possible to learn what I think to be one of the toughest lessons, the mean absolute deviation. Now, what the mean absolute deviation is, also known as the MAD, is when you first find the mean, then you find the distance from the mean, the absolute deviations, then you find the mean of those absolute deviations. The interquartile range, that's where you put the numbers in order from least to greatest. Then you find the middle of the upper half minus the middle of the lower half, and you subtract them, and that's the middle 50%. That's the interquartile range. So right here, I'm going to go over this as quick as I can, keep this video small. The mean of the data set is 3. So when the mean is 3 right here, we want to know the absolute deviations. Now, normally with deviations, if you go down, like if we go down to 1, 3 to 1 is 2 away. So it goes down, it's -2. So the deviation is -2. Sometimes they trick you with that. But they want absolute value. The absolute value means the distance from 0. And the absolute value of -2 is 2. So right here, it is 2. The absolute deviation away from 1. Now remember, the mean is 3. So from 3 to 4, that's 1 away. So the absolute deviation is 1. From 3 to 6, that's 3 away. All right, hope this is helping. We'll go on to the next one. So in this next one, what you'll see is 9 values. In order to find the mean of these 9 values, you add up all 9 values and divide by 9. So you add them up and divide by 9, and we get a mean of 8. Now, I want you to know something. This same data set will be on number 3. This same data set will be on number 3. So on number 3, again, in the other video right next to this one. So all of this is in great detail on the other video, but this is just a very quick version of this. So, all right, so for the mean absolute deviation, you might have to watch my longer video, but just quickly, what we do is, remember on the last one, the mean was 8. So we find the absolute deviation away from 8. So from 8 to 5 is 3. From 8 to 7 is 1. From 8 to 13 is 5. Now we have to find the MAD, the mean absolute deviation. In order to do that, I came up with this great solution here. These are the data values. These are the absolute deviations away from the data values. Then you have the MAD. So put your data values in order from least to greatest so that you can find the interquartile range from there. Then go from the mean to the data values and figure out the absolute deviations. Once you have all the absolute deviations, again, if my mean were 21, 21 to 3 is an absolute deviation of 8. 21 to 21 is an absolute deviation of 0. So once you have all these absolute deviations, add them all up and divide by however many absolute deviations you have. In this case, they're 8, and the case on the screen is 9. And that is the MAD. The MAD here is 2.888. Again, in order to find the mean absolute deviation, first find the mean, then find the absolute deviations away from the mean, then find the mean of those absolute deviations. Now, for this one, notice this is the decimal rounded to 1 decimal place is needed. I messed that up. So 2.88888 rounds to 2.9. So the number of miles Jim walked each day varied from 2.9 miles from his average, not 2.9 from the maximum miles, not 2.9 less than the average or more than the average. It's more and less than the average. So 2.9 more and 2.9 less. So, which is why that one is picked. Give me a second. Carlson. Maybe.
Extra,
Okay. Hold on a second. All right, so in this one, we're finding the interquartile range. In order to find the interquartile range, put these in order from least to greatest, then find the middle. Sometimes when you find the middle, it will just be between two values. And if that's the case, you then go like this to find the middle of the lower half and the middle of the upper half. You then take the middle of the lower half and the middle of the upper half, and you find the average. So in this case, when you put these in order from least to greatest, the middle of the upper half was 42. The middle of the lower half is 28. 42 minus 28 is 14. Therefore, the interquartile range is 14. And the middle 50% of the prices vary from 28 to 42. All right, for this one, the mean absolute deviation of a data set in the table is about 6.7. Does the value 15 deviate more or less than most values? Use pencil and paper, but you don't have to do that. Choose the correct answer below. So I found the mean of this data set, and I got, I think, 18 when I did it. And then 15 was only 3 away from 18, and then 18 minus 6.7. So 18 minus, again, 18 is the mean of this. 18 minus 6.7, I think, was 11.3. So 15 falls between 11.3 and whatever 18 plus 6.7 is. So I got the data value of 15 deviates less than most values, because some values are more than or less than 11.3. See how that deviates more than 6.7 away from the mean? This one deviates more than 6.7 away from the mean. Remember, 6.7 away from the mean was 11.3. So 6 and 9 are both less than 11.3. And 12 is within. And then you go more like 18 plus 6.7 and see how these values compare in it.